So today we're going to do some graphing of rational functions. This chapter 9, chapter 10 is kind of, I've taken both chapters and put them together because they're short, and make one unit out of it. So let's do some graphing. So for values of y is equal to 1 over x, for values that decrease and are positive but not 0, what would we get? So I'm asking here, so I've got x is 1 and y is 1, because I put 1 over 1, we get that. But if I want to decrease my values, to make it easy to get values, something less than 1 would be 0.1. So what would my value for y be if my x value is 0.1? You might need your calculator to figure this out, or you might be sharp and get it in your head, I don't know. But our calculator is super okay. Yeah, it is 10. So after saying that, I go 0.001. You can probably see the pattern with the next one going to be. Yeah, I'm going to do one more. 0.001 will give us 1,000, absolutely. I'm going to keep doing this, but I'm just kind of exaggerating here. So if I go to, how many zeros do I have this one? 0.00001, we'd get you're close, not 10, but just 1 million, yeah. So the whole point of this, as a is divided by a very small positive number, you get a very large positive number as a result. Or as x approaches 0, and this plus sign means from the right, approach, yeah, it goes to infinity. So I can read, I guess. And that's our symbol for infinity. I think you know. Yeah, basically a bully day, for sure.
How did you get the bottom numbers?
We're just picking them. I'm picking them. Because I know the numbers to make them work.
Huh?
I know the numbers to make them work.
But
So.
how did Joseph just yell out 10?
Smart. Smart.
Y equals 1 over x. So then you take your x and then y is the 1 divided by x.
So then you just move the decimal over because it's 1 decimal and that would be 10.
So 1 divided by 0.4.
And if you can't do that in your head, you have your calculator. So let's do the same thing for a negative number. So I got negative. So I want to do now a negative 0.1. What do we get for that, friend? Oops. Judy.
Oh, you, Judy.
One divided by negative 0.1.
10.
Exactly. And its pattern stays the same. So if I go 0.01, that's going to be, you again, Judy, you might as well. Yep. So we got the point. So instead of doing what I did before, let's go to negative 0.000. Same amount of zeros, probably 5 then. 4, 5, 1, which give us. You got it. So in the same way as 1 is divided by a very small negative number, you get a very large negative number as a result, or as x approaches 0 from the left, which that minus sign means, 1 over x goes to negative infinity, which is what that's doing.
Can you go back up for a second?
Got it? Okay.
Are we supposed to write that down? Yeah, because we don't have that.
Which part?
We only have like the first sentence of those like little paragraphs.
Yep, you do. So I need to slow down. Sorry. Okay, so let's go the other way. So instead of x getting smaller, let's make it get bigger. Same kind of idea. So I think I just saw you doing that on your calculator. Yeah, and let's not bother with this two graphs part. Let's go plus or minus 10. So if I do plus or minus 10, we'll get plus or minus 21. Exactly. And 100. Oops, plus or minus. I dropped the crap. Plus or minus 100 would give us.
Plus or minus 0.01.
Yep. That's not supposed to be this. We'll do one more before we go big, plus or minus 1,000. Zero, zero. Good. Okay, and let's go big. Plus or minus 1,000,000. Oops. Give us plus or minus
0.0000001.
Yeah, exactly. So conversely, it's if they get really big, our numbers go really small. Okay, so let's graph this. You got graph lines and I don't. Okay, I'll get my lines here. All right, that and like that. What point can we graph very easily? Yeah, because it always bears 1, 1, right? But what's happening with as it gets bigger, when it gets to 10, it does what? It gets smaller. And as we get closer to 0, because that's what we're kind of doing with our 0.1, 0.01, the numbers are getting bigger. They're getting bigger. So you probably can graph this somehow, but what we do is we just take it and we just kind of go and we graph it, take it to the axis, and we kind of graph it, and make it go to the axis the best we can. And we remember that our axes are our asymptotes, which I don't remember if we talked about asymptotes. Is that a word that we know?
Yeah.
A line that you can't cross. So we can asymptote in that way and that way, and we can do the same thing on the negative side. Again, you just do the best you can. Try and hug the axis. Don't cross it. That's against the rules. And you hug it out on the other side too, because we have a negative one as well. So our axes are our asymptotes. And this shape actually has a name. It's called a hyperbola. And of course, as always, we label our equation. Both axes are asymptotes. Yes.
So the first one we drew, like the x is getting bigger, but the y is getting smaller.
Right? Right here, x is getting bigger, y is getting smaller, so it's going down low.
And then what about like the other line up there?
This one up here. So if I had that 0.1, it went to
10. Oh, yeah, okay.
Yeah.
Are we grabbing the first one or the second one?
We're graphing y is equal to 1 over x. Both of them, we're graphing everything.
Oh, okay.
Because that's the numbers getting, our graph is the numbers getting smaller, so the y getting huge, and our numbers getting, on the negative side, doing the same thing. And then switching it around, it's like plus 10, make it getting small. We're making it smaller, so it kind of fits the shape of a hyperbola.
Oh, okay.
Does that make sense? Is that okay, Judy? Okay. Okay. yeah, you've got this. The graph gets very close to our axis, so we do not cross the graph. Graph gets arbitrarily close. X and y is called our asymptotes, which I've said. When the graph gets close to the y-axis, where x equals 0, it's called the vertical asymptote. And when it gets close to the x-axis, it's called the horizontal asymptote because we have a horizontal line and a vertical line. So, how to find all this stuff? How to find a vertical asymptote? We solve for x in the denominator. So, for example, if we had y is equal to 4 over x squared minus 4, it does not matter at all what's in the numerator because we're finding the vertical asymptotes. It's that whole thing, what if we divided it by, and we got an error, what would make it 0 in the denominator? That's our vertical asymptotes, because that's the asymptotes. So whatever it is, we just take our denominator, set it to equal 0, and solve. So if we had this, what would we do? So this guy's saying add 4, which is fine, but it also makes me nervous. Because when you do what next?
Well, then you would square root.
Yep, and what will we get? And that's what makes me scared. Because that's only half the answers. So what I like to say is I want to factor this right here. What's x squared minus 4 factor? Absolutely. When we factor it, we don't miss out a factor. So you could do that square root thing, but when you square root it, it's not just 2, it's
Like it's gotta be
plus or minus 2. And if you can remember that, that's super okay. But if you don't remember that, it's going to be the opposite of good. Questions here? To find the horizontal asymptote, 2 ways. If the degree in the numerator is less than the degree in the denominator, it is y is equal to 0. Like this is. So for this one right here that we just did, y is equal to 4 over x squared minus 4, our horizontal asymptote would be 0. Because it's less. Because what's the degree in the numerator? Yeah. This is grade 9 stuff I was going back there. At least we're doing it in grade 9 right now. Because the degree here clearly is 2 because that's the exponent on it. What's the exponent on this term you know? Is it? If we had x here, what would be the exponent on it to make it not be there?
0.
Yeah, so it's actually 0 degree. So clearly 0 is less than 2. And it doesn't matter if it's something that's not that complicated. It could be something just like, I'm just kind of the whole deal is the degree is less in the denominator, so that makes it y is equal to 0. And it does not matter what comes after the degree because, again, this is grade 9, so you probably don't remember. Degree is the biggest exponent, so the cube and the 9, it doesn't matter. It's just the biggest one. Questions on that? Is that okay? Because you're furrowing your brow with what's going on, maybe. That's fine.
Well, wasn't the degree in the numerator on the first example less than the degree in the denominator?
Yeah, it is. So I'm just making it super clear because that's
Well, then y was 0 in that one as well.
yeah. Yeah. The other thing is, if the degree and the numerator and denominator are the same, then y is going to equal to whatever the ratio of the leading terms are. So, if I had something like y is equal to 4x squared plus 8x minus 9 over 8x squared, again, it doesn't matter anything after our leading terms because the leading terms are equal. So we have to take our leading terms and reduce them, and that's going to be our horizontal asymptote. So our leading terms on this is
1/2.
yeah, so that would be y is equal to 1/2. So whatever it maps out, that's what it is. But sometimes we have to be careful because it might not look like it's that it is. Um, I got 5x cubed over 3x squared plus 1 times 4x minus 3. You might think, well, it's bigger on top. We don't do those. And we don't do those. That's not our curriculum. If you keep doing math in university, you'll probably hit that. But if we take the leading term from each bracket and multiply them, right? So we'll have our 5x cubed over 12x cubed. And again, everything else doesn't matter. So our horizontal asymptote is the y is equal to 5/12, or whatever it is.
What's supposed to be written after the equal sign, like in a question?
Nothing, because that's our answer. 1/2, it's 5/12. That's the ratio. It's equal to the ratio, which we just figured out. Any other questions? And some other information to find the x-intercepts, we solve for x in the numerator, and to find y-intercepts, we set x values to 0 and solve. So let's just do that for an example. Okay, let's graph. Let's graph one. Let's graph y is equal to 4 over x plus 3. And I'll give you the list when we get to the evaluation on this and what you need to solve so you don't forget. I'm just giving you the order that I like to do it in. Don't have to do it that way, but we do. I'm doing it this way. So I'm starting with x-intercepts. How many x-intercepts are there? What does it say in the page before? There? No, there's none. Because there's nothing to solve for x there, so there are none. And that's fine. That is fine. So probably going to ask about y-intercepts next. Absolutely. So y-intercepts. You get y-intercept again. Set x equals 0, okay. So equal 4 over 0 plus 3, which would be 4. Yeah. So then as an ordered pair, that would be, what's x equal to? 3. What did we say x equals to? 0. Yeah, and 4 over 3. Exactly. So then it's a fraction and all that. You just make your best estimate. Make it look reasonable. That's all good. Vertical asymptotes. What would our vertical asymptotes be? And how'd you get that again?
Because we said x equal, we're self-evaluating.
Yeah. X can't equal -3. That's exactly right. Yep. And our horizontal asymptote, I'm going to slip it over here. Is going to be what? Horizontal asymptote. No. That's the y-intercept. Let me find our horizontal asymptotes again. Quick. In the back corner there. I'm looking it up. About the degree, the numerator, denominator. So what would the horizontal asymptote be for this one? Yep, absolutely. And it is less on top because it's just a number. So y equals 0. That's right. But if it's the same, then we take the ratio of that. Okay, this next part, I don't know if you've done before, but we have to do a sign analysis to tell us where the graph is above or below the axis, the y, the x-axis. sign analysis is we list our factors. This first one will be small, but our next one you'll see how there's a little bit more to it. When I say list our factors, I'm saying list all of our factors in the numerator and denominator. So what's in our numerator? 4. What's in our denominator? X plus 3. And then we basically make a number line that doesn't have to be scale. And what I recommend you do is just what do we have to put in for x to make our numerator or denominator 0? So that is what we put in there. Let me ask ourselves, all the numbers before 3 and before -3 and numbers after -3, is that going to change the value of 4? Is there a variable to change the value of 4 on it? No. So what is 4? Is it positive or negative? Yeah, so what is kind of, all right, it's positive. Absolutely. Now, for the x plus 3, what happens at -3? We get what? Yes, so we put that there. But before -3, like if I put a -4 or -5 or -2000, we're going to get what kind of an answer? And then my question is it positive or negative? 4. Like -4 plus 3 is going to be what? Positive or negative number? I don't even care what.
Negative.
Yeah, so, and like -10,000, it's going to be negative. So up to 0 is all negative. But after 0, it's going to be positive because, of course, 3 minus 2 is going to give you a positive number. Absolutely.
So what were those positives that are all positive? That's it for 4? Like if 4
Is
would
that-
have to be
Is
positive?
that 4 a positive or negative number?
It'll have to be positive, right?
It's positive because it's positive in the question, so it's all positive. There's no variable on it to change
Okay.
the sign on it.
And then for that, that's the x, like the ones that are negative and then positive?
Because we're putting the value for x, because like if I had -5 there, -5 plus 3 is going to give you,
Negative.
I don't even care that's 2, I care that it's negative,
Yeah.
or we care that it's negative.
Oh, okay.
So all these, if we put in for x, it'd be negative, 0, and then positive. Is that okay, Judy? Okay. Because now we multiply the lines. What's the positive times the negative? Right. But now here, a 0 times any number is going to be 0. But this is in our denominator, isn't it? So what is that? What is that right there? I think the 3 is it's our vertical asymptote. So if it's a vertical asymptote, we don't put 0. We're going to put down infinity because our graph is going to go to infinity. And then multiply these two lines, of course, positive times a positive is right. And that tells us where our graph is going to go. And now we graph it. So, paper or somewhere, just draw a graph and, yeah. So when I'm doing these graphs, I like to use where things are happening to kind of give me information as to where I should put my numbers so I don't put more information. So I see a vertical asymptote happening at -3 according to my sign analysis and from my work, so I'm going to label -3. Okay, so I've got -3, so I'm going to use 3 as what, oops, I labeled because we have to have scale on this thing somehow. And again, our y scale does not have to be the same as our x scale, but for this one, it sure can be. So I like to start by putting in my asymptotes, not my asymptotes. Yes, my asymptotes. Absolutely. So with a dashed line, I put in my horizontal and vertical asymptotes. So where are they going to go? Yeah, so my horizontal one is, you know what, I'm just going to make them this green so it can go over top. Is that 0, and that -3 is the vertical one. Absolutely. And we can't cross them. And we use dashed lines for asymptotes. We just do. What else do we know? So is there an x-intercept? But what's the y one? 0, 4, 3. Absolutely. And that's a thing. So we label it, and we label it. And it's a thing. Is there anything else that we know? Any more intercepts or asymptotes or anything like that? No. So then we use our sign analysis to tell us where we're drawing our graph. So before the vertical asymptote, what is the graph? Well, we look at our sign analysis, it's all negative. So before the vertical asymptote, my graph has to be negative. And kind of hug it out with the asymptotes. And all you're doing is you're drawing your graph based on what the sign analysis is telling you. Which is it's all negative, so it must be below the x-axis. So I guess I just have to hug it out, do the best I can, and draw that. Yep.
Then what's the y-intercept?
However, above, after it, we have the y-intercept. So we can use that to guide our hyperbola, because it has to go through that. So I'm still hugging it out with the asymptotes, but my information tells me I have to go through there, and then kind of have that. Because after the vertical asymptote, it's positive, so it has to be above the x-axis. And of course, somewhere right down the equation. Questions on the first one?
If 4 is all positive, how do we know the next one?
Because 4 is 4, and it is 4. So what is 4? Is it a positive or a negative number? So it's all that. If there's an x on it, we got to do something with it.
Yeah, but the next one, how do we know what it's negative?
Because give me a number before -3. Doesn't matter what, anything. So what's -4 plus 3? So it's I don't care that it's 1, but I care about if it's positive or negative. So -4, which would be here, would be negative. In fact, -5, -6, -10,000, they're all negative. But if I pick -2, -2 plus 3 or 3 minus 2 will give us, no, it'd be 1, which is positive, so then it's all positive after that. So that's why they're all positive. Okay? Yes?
Then how do we know, how do we use that to know if it's above or below? Like,
Because if it's, oops, I want it, come on. If it is negative, it's below the x-axis, and if it's positive, it's above.
and that's our x if it's.
The graph. I thought I was answering your question. Did I or did I not?
Yeah.
Let's do it. I got you
If
more.
what's negative, or if what's positive, what are you supposed to look at to know? The bottom line?
The bottom line, yeah. The line that we multiply together.
Are those supposed to be negatives?
Yeah.
Those dots?
They're not? Oh.
But this heading item? I'm so
And
confused.
these ones that have some
So negative then? Or what? Because I have no idea.
I'm gonna do another one. Okay, and see if that helps.
So the 4 and the x plus 3, those don't matter.
Yeah. So this is why I want to do another one, because maybe doing another one, we'll see how it kind of goes together. Because, yeah. And if that doesn't help, then we'll back up and I'll try again. Oops. So this one is graphing a y is equal to x squared minus 36 over x squared minus 4. Again, I like to start with my x-intercepts. Except this time I've got something going on. Because where do we find our x-intercepts again? Numerator, so what do we have to do? Yeah, I guess so. Sure. And again, if you remember the plus or minus, then do it. Oops, that's not right. Plus 6. So, just because I'm me, when I get my intercepts there, I like to put them into ordered pairs. So what would the actual x-intercepts be in ordered pairs here?
Plus or minus 6.
We have to put them separate. So,
Negative 6 and 0, 6 and 0.
yeah. So what you said wasn't wrong, it's just you have to separate them. So there we are. There we have them. Yep, good. It's good. Y-intercepts. What do we do to get our y-intercepts?
Sorry,
So we have what left over?
just negative 36.
It's equal to. So our order pair would be? You got it. You got it. Should be here. I guess I can squeeze this in here. Let's go vertical asymptotes. Yeah, and to try and keep things straight, I try to remember vertical asymptotes. Wait a minute, that's where it can't be. So that tells me denominator, I hope. It can't be, we can't divide by 0. So we get yep, you know what? If you remember that, that's great. And the same thing like I told with this other thing, let's just write them down. Somehow, if you don't remember, I'm sorry, if you don't forget that there's 2 with this plus or minus 2, then fine. I'm not going to die over this x equals 2, x minus 2. It's just, I'm just trying to remember information. That's all I'm trying to do. And I'm just going to squeeze stuff up here. I want to squeeze my horizontal asymptotes up here. Because this is a nice one. Mathematically, I think. Because it'd be what? Yeah, because our degrees are the same. So x squared over x squared. So y is equal to 1. Absolutely. Questions to here? Okay, let's do the sign analysis. And again, the sign analysis has all the terms factored in. So our numerator, what's our numerator factor? what's our denominator factor?
X plus 2.
Yep. And again, I'm not concerned about the scale of your number line here, but just mark off where we're going to get 0. So where we're going to get 0. By putting in that values for x, what's going to make our factor 0 is what I want to say here.
How do we do that for both of them?
One at a time. What makes this one 0? What makes that one 0? What makes that one 0? And that one 0? That's what I'm talking about. The scale, I don't care, but just make sure that they're in the right order for your number line that's proper. And again, this is just what I like to do. I like to put in my zeros. Where does x plus 6 give me 0? Well, you told me already. So I put my 0 there, and then my 0 there, and then my 0 here, and then my 0 there. Because for each of those factors, that's what gives them 0. And for this one, what are my signs before all the zeros? Yeah, because if I put in like a -7, that's going to be negative. If I put in 5 minus 6 is going to be negative. So yes, these are supposed to be negatives. Currently, they won't back you up how good your negative signs are, just make them look negative-y. Then after the zeros, we're going to get positive, yes. Yes. Questions to hear? Okay, before I start multiplying my numbers up, I like to put my asymptotes on the bottom line, because where are the asymptotes occurring? The vertical asymptotes, I should say, I'm sorry.
-2.
So I do that because I know it's not just going to be a 0 when we get to there. But then I do the multiplication of our lines here. Negative times a negative times a negative times a negative is a, yeah, and it's positive until we get to what? Because it becomes what? Yeah, 0, because we have a 0 in there. No positive, it's all fixed down. And then between -6 and -2, it's going to be negative. It is. And then we hit an asymptote, I guess. And then between -2 and 2, a positive times a negative times a positive times a negative.
Positive.
Who's right? And then from 2 to 6.
Negative.
And then at 6. That's at 6. And then positive, yeah. So if it's 0, it's telling you it's crossing the x-axis. Yep. Okay. Let's graph this poopsie. That's not the one I want. And again, I'm putting numbers where it's happening. So I know that stuff is happening. And I direct draft a little bit. But let's change our scale going for our y. We'll go 1s here, but I'm going to go up by 2s. And up and down by 2s for the y-axis, just to make it fit a little nicer because we need our y-intercept at 0, 9. Or you can make it going up by 5 if you wanted. The y-axis doesn't matter. But before we start graphing, we need to get our asymptotes in here. And where are they? Okay. One there, one there. There's our vertical ones. Yeah. So got a horizontal one going at 1. Oh, I don't like that. Move that up a little bit. This one's kind of in the middle since I'm going up by 2. Okay. So this next part is something that I like to do. I don't know if you like it, great. If not, you don't have to do it. But I like to label my y-intercepts. I'll label them blue here. So you have to cross there. Or not my y-intercepts, but my intercepts. I'm going to cross here. And then my x-intercept or y-intercept was right there. And now I use my sign analysis to tell me where to graph. And go through my intercepts. So according to my sign analysis, what do I do before -6? Yeah, so that means I have to be above the x-axis, but below the asymptote, so I just have to squeeze it in there. Like that. Squeeze it in there and then cross, and then just, after you cross that, you make your best estimate. That's all you can do. You follow it out, you hug it out, it's an asymptote or hyperbola, and away you go. And that follows it, because it's plus, 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 crosses, it's 0, and then it's negative, all the way to infinity. But my next section between -2 and 2, it's all positive. But I have to go through the y-intercept. So how would I draw that? So error draw that again?
Like we start at -2 and then go up to the 10.
So like how, like this, or what are you saying?
Yeah, pretty much.
So then what's happening with this line here? That looks really weird. We'll draw this again.
Well, then we have to start at the -2 and go
Right, so how do I start at -2 and be all positive, cross through that point, and finish positive? You're 1, but not quite.
Oh, yeah, we have to finish positive.
Yeah, and start positive. From infinity,
Start positive on the x-axis or both?
in this section. From here it goes to negative infinity, but there we start at positive infinity. So I haven't drawn this shape yet, so I just thought see if someone could come up with it. But to stay positive and go through the intercept, well, we're positive, we go through the intercept, and we stay positive. So we're just drawing a parabol kind of thing to make it fit. And that fits everything. But we're not quite done, because I have a negative. Sorry, from the asymptote, I've got negative, 0, and then positive again. So with that to draw. How could I draw all negative, hit 0, and finish positive?
Do like a reverse of what you did over there.
Exactly. So I'm all negative, hitting my 0, and I'm staying positive, but not crossing the asymptote. And there we have it. Oh, and my y-intercept thing, so I guess I forgot to label that. I better get that on there too. Oh, I guess I've got x-intercepts to label here. Holy cow. Lots of things to not forget. Which I forgot. Put it into me on here. Yeah. Did that answer any of your questions, Judy?
Understood understand how you got that, but I just don't understand how it went on to graph.
This part here,
Yeah.
wherever it's positive, has to be above the x-axis. Then my x-intercept is and then it's 0, so I cross through 0, and then it's negative to infinity, so the vertical asymptote takes the line to make that hyperbola shape all the way to negative infinity, so it kind of keeps going down in that direction. In between these two infinities, which are vertical asymptotes, we have all positive, so to make that shape, is that, and then we'll do intercept, because we have to look for the intercepts. We have to. And then the next negative, then 0, again, it cuts off at the vertical asymptote, all negative, and then 0, which is at our 6, and then positive, it's just in that little space in between your horizontal asymptote and the x-axis. So it's positive above the x-axis. Kind of deal. I have one more, but that was going to go. So what I plan to do tomorrow might change already. If you want to get started in your deal time, here's some questions. They're 4.4, 1 to 9, but not 6 and 8. I don't like them. I'm going to give you another example tomorrow. We'll figure out what we're going to do then.